Hello, Math 7 students. We are still working in Module 3, and today we will be working with Lesson 5, which is called Collecting Rational Like Terms, and that can be found on page 86 in my comp book. So we're going to go ahead and turn to page 86 in my comp book. Collecting rational like terms. Now, we already did a lesson that was just called Collecting Like Terms, and the reason why I decided that we needed one more lesson on this is because when they're rational like terms, that means that it could be fractions, it could be decimals, it could be whole numbers, it could be positive and negative integers, all of those kinds of things. And so we needed to do one more quick practice of collecting like terms. So our goal for this lesson today is, we will write a number of expressions by collecting like terms and using the distributive property. The question that I want you to think about is, what must you remember when combining like terms? There is one specific thing that you have to be aware of all the time. So we're basically just going to do an example of combining rational like terms, and you'll notice that we have rational like terms in here because we have a 3/7, a 1/3, a 1/7, a 1/4, and then we also have 6, and we also have 1, and we also have 1 as coefficients. And so this is a good practice to see what we can do. So we have I, 6 plus 6i, minus 3/7 I, plus 1/3 h, plus 1/7 I, minus h, plus 1/4 h. That's what they're asking us to combine. So we're simplifying the expression into the smallest form that we can. We cannot solve it because we don't know what it's equal to. The only way that you can solve it is if somewhere somebody tells you what something is equal to. And we don't have an equal sign anywhere on here, so we know that all we're supposed to do is simplify it. So the first thing that we need to do is, it says first, look for the parts of the expression. So we have some i's, and we have some h's. Okay, so those are the parts. You're looking for the variables that have things in common. So we're looking for the parts of the expression. The second thing says combine the common parts by shape. So you will notice all of the i's, I drew rectangles around them. So this is a rectangle, this is a rectangle, this is a rectangle, this is a rectangle, this is a circle, this is a circle, and this is a circle. So I chose rectangles for i's, and I chose circles for h's. Now, do you have to do that? No. But it is a very, very helpful way of organizing the things that have in common, so you only combine the ones that are common. Okay? The third step is add the opposite for subtraction. So we have a subtraction symbol here. So I went ahead and said that subtracting is the same thing as adding the opposite. So you add, what is the opposite of 3/7? Negative 3/7. So it now says I plus 6i plus negative 3/7 I plus 1/3 h plus 1/7 I. Oh, and we have another subtraction, so we're going to change that by adding the opposite. So what is the opposite of h? Negative h. So plus 1/7 I plus negative h plus 1/4 h. So we changed all of the subtraction symbols or signs into adding the opposite. Okay, nice job. Last, combine like terms to simplest form. So this is where the shapes come in handy because you're only going to combine rectangles with rectangles. So if you take a look, we have I plus 6i plus negative 3/7 I plus 1/3 h plus 1/7 I plus a negative h plus 1/4 h. And now we're going to take those and combine them. So we need to know that this I right here has a coefficient of 1, but we have a common denominator right here of the fractions that are connected to I. So I went ahead and said that the common denominator would be 7. So if this is a 1, 7/7 is the same thing as 1. So this is 7/7 I to cover this I. 42/7 covers the 6 because 42 divided by 7 is 6, plus a negative 3/7, it was already a fraction, I, plus 1/7 I. So all of those have common denominators now, and now we can combine them. Then I decided to go with the circles, knowing that this said 1/3 h and this says 1/4 h, so a common denominator for third and fourth would be 12ths. So what I do to one side, I have to do to the other, so 1/3 becomes 4/12 h plus a negative 12/12 because there's a negative 1 in there, the coefficient, so it's negative 12/12 h, plus 1/4 becomes the same thing as 3/12, so that they all have a common denominator. All right, now we're going to simplify. So we're saying, okay, well, 7 plus 42 is 49, right? Plus 1 more would be 57. So I went ahead and combined the 7, the 42, and the 1, and I got 57th I. Then I added the negative 3/7 I, so that's how I simplified that side. And now I'm going to move over here and simplify this side. So I know that 4 and 3 make 7/12 h, and then I have minus a 12/12 h. So we can now combine these because they're organized in that way. So 57th I plus a negative 3/7 I gives me 47th I. Whew, that's a hard thing to say. Plus 7/12 h plus a negative 12/12 gives me a negative 5/12 h. And that is all done. Okay, that is the simplest form that it can be. And so we know that we have the simplest form. And so that's how we know that we're finished with this one. We cannot simplify it anymore because we don't know what I is, we don't know what H is. This is the simplest or the smallest form. So I want you to look at this. We went from an expression that was this big down to an expression that is this big. And that's the whole purpose of collecting like terms, because once you have them in the smallest form possible, it's easier to solve once you're given the value of the variables. Something that I want you to add in there is you need to remember when you're collecting rational like terms, if you have fractions, when you add or subtract fractions, there must be a common denominator. And you saw me go ahead and throw that in there so that you could see it. It is fun. It is kind of challenging in the sense that you've got to make sure that you keep track of all the parts. But once you figure out and you feel comfortable with doing it, this is a really easy task. So let's go back to our goal for today. Our goal for today was, today we will write number expressions by collecting like terms and using the distributive property. You will be doing that with some more of the practice that I give you in class. The question, what must you remember when combining like terms? I'll give you a big gigantic hint. These all have rectangles because they all have I's. These all have circles because they all have H's. So what must you remember when you're combining like terms? We'll talk about that in class tomorrow. And that's it, my dears. See you all tomorrow. Bye.